In this video, we're going to look at trigonometry and the three ratios, which is sine, cosine, and tangents. First, let's have a look at some key words and some features of a right angle triangle. We normally focus on one angle. We very often mark it as theta. Okay, and we need to know that the longest side, which is opposite the right angle, is called the hypotenuse. We also need to know that the length opposite our angle theta is called opposite, and the length or the side right next to the angle is called the adjacent. We use trigonometry. We can use SOHCAHTOA to help us remember how to use the three ratios. So the sine ratio involves opposite and hypotenuse. The cosine ratio involves adjacent and hypotenuse, and the tan ratio involves opposite and adjacent. And it is very important you can identify which ratio you need to use, and then be able to rearrange the formula to make sure that you find the correct value. So in my example, I have my angle given, which is 34 degrees. I have one length, which is 12 centimeters, and I've got x. It's very important you can identify what's given in the question. So I know that x, because it's opposite the right angle, this is my hypotenuse. And I know that 12, because it's right next to the angle, this is the adjacent. So I need the ratio that involves hypotenuse and the adjacent. So I can see that that ratio is cosine. So I need to use this triangle to find the value of the hypotenuse. Because this is what I'm trying to find. I'm going to cover h in the triangle, and I can see that to find the hypotenuse, I have to divide the adjacent by cosine theta. So now I can just substitute the values into this formula, okay, and that will give me the value of the hypotenuse. Now the question is asking me to give the answer to two decimal places, so I put this calculation into a calculator and round it to two decimal places, which is 14.47. In another question, I have some values given. I know one length, and this is the side right next to the angle. I've got the angle, and I need to find the value of x. So the value of x is actually the opposite. You can see that this is the side opposite the angle that we are given, and 4 is the adjacent because it's right by the angle that we are given. So now I need the ratio that involves opposite and adjacent, okay, and I can see that the ratio I need to use is tan. So now, because we're trying to find the opposite, this is the part in the triangle that we need to cover, and we can see that to find that value we need to multiply tan theta by adjacent. So tan theta, that's tan 52. Please remember to put it in brackets and then multiply it by 4 because this is the length of the adjacent. Okay, and that gives us the opposite. Okay, please remember this is not 0, this is 04, the opposite. Okay, and we put this into a calculator and write the answer to two decimal places, and you should get 5.12. In another example, I've got again one angle and one side given, and I need to find the value of x. So first you need to identify what's given in the question. Now 7 centimeters, this is the length of the hypotenuse. As you can see, this is the longest side, which is opposite the right angle, and x is the opposite side because it's opposite the angle that we are given, which is 62 degrees. So I need to use sine because this is the ratio that involves opposite and the hypotenuse. So we need to cover O because this is what we're trying to find, and we need to multiply sine theta by the hypotenuse. So you put the values into this formula. Remember again to put the angle in brackets, and you multiply it by 7, and this gives you the value of the opposite. Again, remember that here we have O and not 0, and you round the answer to 2 decimal places, and that is 6.18. In the next example, I have two lengths given, but I want to find the angle. Okay, so again, we need to start by marking or labeling what we have in our diagram. So 6, this is the hypotenuse because it's opposite the right angle, and 5 is the opposite because it's opposite angle x. So I need the ratio that involves opposite and the hypotenuse, and that is sine. So I can substitute the values into the right equation. Remember, to find the value of the angle, you need to divide opposite by the hypotenuse. But now you need to remember to use the inverse function on your calculator. So you need to press shift and then the sine button. Okay, so we want to use the inverse function, and then we divide 5 by 6 and we get the answer. Again, the answer needs to be rounded to 2 decimal places, and that is going to be 56.44 degrees. In my next example, again I have two lengths and I need to find the angle. 5 centimeters is the opposite because it's opposite angle x, and 3 centimeters is the adjacent because it's right next to angle x. So I've got adjacent and opposite, so I can see that the ratio that I need to use in this example is tan. Okay, so we substitute the values into the formula. We need to divide opposite by the adjacent. We put the values into the formula, but then remember we need to use the inverse function again because we're finding the angle. So the inverse of tan, and then we divide 5 over 3. Remember, to get the inverse function, you need to press shift on your calculator and then 10. The answer to 2 decimal places will be 59.04. In the final example, I have again two lengths and the angle that is unknown. So first I label the two lengths. Okay, 17 centimeters is the hypotenuse because it's opposite the right angle, and 14 centimeters is the adjacent because it's right next to the angle. So I want the adjacent, I've got the adjacent and I've got the hypotenuse. That means that the ratio I can use is cosine. Okay, we're trying to find the angle, so we need to divide adjacent by the hypotenuse. We substitute the values into the formula, and remember to use the inverse function to find the value of the angle and round the answer to 2 decimal places, and that is 34.56 degrees. I've got 3 examples for you that you can try, so you can pause this video, have a go, and when you're ready, press play again. Here are the solutions, and I hope you got them all right.